I have projects like this when they come back to me and I said, yeah, very nice that you have a brand new low voltage switchgear here and here. Finish calculation and turns out it's like 80 calories. And they are surprised because it's new.
Yeah.
Yeah, it's new, but it's the same generally in electrical words. We have to give people numbers so they can identify the hazard.
Welcome to the Electrical Safety Podcast. Today we have the pleasure of hosting Marcin Ruta, a power system engineer and expert in arc flash risk assessments. With over 200 power system studies completed across various industries, Marcin and his team at MR Power Tech have established expertise in areas such as short circuit studies, protective device coordination, and arc flash studies. Marcin has worked with various clients across Europe, the Middle East, and Africa, and in all sectors, including industrial manufacturing, automotive, oil and gas, chemical, and renewable energy sectors. We're excited to hear more from Marcin about electrical safety and power system engineering. Marcin, welcome to the show.
Welcome everyone, and welcome you, John. Thank you for the invitation here.
So just to kind of get things going, would you mind giving the audience a bit of kind of your background story and how you got involved in doing arc flash studies?
Oh, as everything in my life, a bit of by accident. Or it wasn't really my main goal when I was starting engineering. So just to give you the short overview. So the city where I'm born, there is an old factory, so old company, Polish company that used to build all the electrical equipment, called Apena. And I started work there after my university. There's also a fun story, but a bit longer. And after that, they already been bought by GE, General Electric. So I joined corporation in the very, very, very beginning. And it was quite fun, 3 years. So generally I did a lot of low voltage switchgears manufacturing, I would say. So design, pre-design, and then make it happen. The customer, FAT, SAT, everything else. But after 3 years, I kind of stopped it, left it, looking for something different, and I joined the last job in Poland that I did some in maintenance. Generally speaking, so we were moving factory from France and Belgium. I didn't like it very much. So at that time, I decided to move abroad, and I end up in the Netherlands, where we started with design the wind turbines for STX Wind Power. It was quite fun, but unfortunately, the company didn't went well. They bankrupt. They bankrupt later, but I left earlier a bit. And luckily, I found Eton that time, and it was, I would say, lucky shot. I found the company. Actually, I found the very nice, interesting people there. That's why I take the job. Went and it was many years ago. I don't know, 10 years ago or something like this. So that was the part where I actually started doing all the power system studies engineering, all detailed electrical engineering. The place where I used to live in Netherlands as well, place where they had the factory for the low voltage and medium voltage switchgears and equipment. Oh, it's still there, and I still know the people, so it was very nice. And that time I started actually with arc flash. I went into details, deep down to everything, and it started to be very interesting. And at some point, 4 years ago, I decided to start my own company, all the things on my own.
What are the main factors? Getting a little bit more detailed into arc flash study. What are the main factors that you consider doing arc flash studies? Is there some specifics that you can share?
Well, this I would say there is no specific I can share. It's just the way how you're supposed to do the arc flash study is written by norms and standards technically. So you can only do it a bit wrong, or you can do it correctly. You might do some extra things that maybe I'm doing. I don't know. So in practice, if you follow an FPA or Canadian CSA standard as a guide, or generally what has to be done, then you have IEEE 1584 or technical specification how to do the study, which also is telling you what's supposed to be in the report as an outcome. And there is one additional standard which is probably less known as IEEE 1584.1. There's really specification what's supposed to be in the report, and there was a revision last year of the standard. But then you have already like 90% of things that you have to do. That you have to do all the, precisely collect the data, make all the short circuit calculation, but not like only one scenario, but you have to look into all operation modes, like with the parallel transformers, with a lot of motor on or off. Yeah, you're looking for the edge on the calculations, so minimum, maximum, but there are also things in between which you have to take into account, and it's not really looking really extreme minimum, maximum, but kind of realistic cases as well. So because you might go, let's say, over conservative on everything at some point. And as far as I see, what makes a lot of troubles to people is the protective device coordination, or I call it selectivity study, where you verify all the protection settings, let's say this way, and then you provide recommendations. So generally, the recommendation part seems to be kind of hard, I would say, for some people or some companies when they struggle with it. At least when I see on the projects, when I sometimes some installations after other company happens sometimes, not very often, but sometimes. And then there is one big, I think, related with recommendation. When you also, I skip one thing, when the short circuit, you also do evaluation of equipment, which is quite easy thing to do. Then provide recommendations, what you have to do to make it okay. And at the end, there is one big part behind it, the way how you communicate it with people. For example, so they have to understand what's happening.
Mm-hmm.
Only that you show them, a lot of technical things. We report that has 1,000 pages and all kind of attachments, but at the end they have to understand what's really happening. Because if they don't understand, they will very easily and very fast they will just get bored on this or get frustrated. So I have one customer actually now that it's not the new customer, but it's existing for a few years already. And actually, I didn't change anything in my approach, but I think what changed is the external audit or auditor is new, and he starts to ask questions. And now I think he got a bit of confused or lost some of the recommendations I have. So I actually have to make a big step back and explain him a little bit much easier way what he needs to do. Like
Mm-hmm.
step by step, only few things selected, not everything that he needs to see. Like laser focus on what precisely has to be done.
Yeah. You find there's a big, like, for maybe a lot of just health and safety people or managers who don't have an electrical background and an engineering background, maybe they don't quite understand exactly what the arc flash study is doing. Just like, in as basic of terms, the way that you look at it, fundamentally, what's the purpose of the arc flash study?
Well, for me, it's the numbers. We have to give people numbers so they can identify the hazard. Let's say that's the first thing. I know there is a word risk in ACFA's risk assessment
Mm-hmm.
nowadays, but in fact, for me, it's like as an engineer, you come back with the numbers, you tell what's the hazard, then you can check, of course. But in fact, for me, that's the first thing, identification. It's not really in the hierarchy of controls, but I always like to add it that there is on top identifications.
Mm-hmm.
You identify the hazard, that's the first big step that you can do to anything else. If you don't know what's happening, there is no magic solution that you can do, because now you are kind of blind, and you start to exchange the switch gears, maybe add some arc flash detection or protection or quenching, which costs money as well. And it's kind of, I have I have projects like this when they come back to me and I said, yeah, it's very nice that you have a brand new low voltage switch gear here and here. Finish calculation, and it turns out it's like 80 calories. And they are surprised because it's new.
Yeah.
Yeah, it's new, but it's the same
Yeah.
generally in electrical words. So in my feeling, the main thing is just to answer the question: what's the hazard level? What's happening now? There are a lot of things later that you try to eliminate, reduce. So there are a lot of work that you do later. But the first thing is, like, let's say, what's happening. That's the first thing.
Installing new equipment does not necessarily mean that the customer will get a safer system.
Well, technically it will, because the rules are the new. So you have to manufacture it according to the new rules, new regulations, everything else. So in some certain point, it will be safer, especially if you have like something built in 80s or 70s, and you just buy the new equipment. Then that makes a big difference. That's part of risk, I would say, of the likelihood, part of estimation of risk, where you can say, yeah, this is new and everything's supposed to be better.
Mm.
But as well, it's this is not the rule of thumb, because you might buy most everything you want. There are some limitations as well to it, but if you are the customer that is, I don't want to use word unaware, but you just look on money and there's limited budget, and you say we have to build this, but let's take the separation form 2, I don't know what's 4B, and so on, or like for the UL switchgears as well. And yeah, and you might buy it as well new equipment which is uh, kind of old technique, old style, I would call it this way. So that's part of what I yeah, put a lot of focus to people to explain as well, that when we do the study calculations, we also create the model. So we have a digital twin. Based on this digital twin, we can do much more things than ArcFlash only. So that's partly I already do it in the first place. That's why we do all the short circuit evaluation. We do all the equipment check. We do sometimes load flow as well, which is not
Hmm.
necessarily needed for the ArcFlash, but as
Right.
an overall, it's a good check for the system. You might as well add the selective or protective coordination check, and then provide recommendation that you see that everything is not okay. You have to improve it to make it better. That's something that let's say software unlocks for us. It's
Yeah.
making much easier to do it for me this way. And if you go like follow these steps, you follow, I don't know if what software you can use, but it's Easy Power, SKM, ETAP, or Dixieland, or I don't know, SIME in Canada. Then generally they do similar things, different ways. But at the end, it's the way that you have digital model of your system, and you might do as a lot of things with it.
Hmm.
It's not only like,
So,
if you see Excel calculations, they not necessarily are bad, but for sure they are not flexible. And if you have to do it, redo it in 2 years, 3 years, 5 years, yeah, that's a big advantage of having this digital model as already in place.
so for those people that don't know, could you just kind of, from start to finish, walk us through, what a typical arc flash study project would involve? Like, what would all of the steps be that you'd be involved in?
Yeah, so like A to Z, um, technically it can be covered by the company as mine, for example, but all the steps are quite easy. So the first one is always the contact, and let's say we can drop it like the commercial contact, everything else. So you have to have a contact. You have to kind of educate people a bit in the very beginning, so they understand what really will have to happen, or what are the steps that will happen. Then if we pass all the commercials, so pricing and making an offer and making the purchase order, end up in the usually kickoff meeting. It can be by Teams or virtual meeting, but or on site. Usually there is a kickoff meeting. There is one thing in between where people struggle with because sometimes there is so little documentation.
Hmm.
No one can tell really how big this thing is. You will
Hmm.
have a problem to price it. Then you have to go on site. There's no option really. Um, Sometimes there is one step in between where I actually visit the site to have an idea what's really happening, to be able to make an offer. That's the
Hmm.
point. But if you are in the offer that we start the project, then the first thing is really kickoff. Then we collect the data from site, which means that we have to collect every information needed to create the digital twin. of the system. Which means all the transformers, breakers, cables, switchgears data. There are more switchgears data now. I don't know, generators, UPS, DC batteries. I don't know what else can be. Groups like dynamic rotary UPS that I have few last project price. I don't know, photovoltaic panels, solar panels that you might have, or kind of gas generators. You name it. It's always like you always have to check it. We collect all the data from the site. I do it already like kind of half digital way, but most of the time you want to be very short on site, as short as possible, because sometimes you have to switch off something, or you have to do it with the customer to switch off something. So it really depends on the site. Are the possibilities. Once this point is finished, you might do a few things, but in practice, you will start the modeling. So there might be some discussion with the customer on the missing data. Maybe we have to go back to the site in different time. But in practice, you already can start, like you have 80 or 90% of data, so we can start the work. Usually, there is no customer involved in this. Again, it depends on site. It's like huge site with a lot of nice engineers on site that they know what's happening. They might be helpful, and they like to be involved in the process. I mean, most of the customers won't be involved because, it will not help here. So it's the consultant work now, engineering work. Once we prepare everything, prepare the model, prepare all the studies, and then you might have missing something. I don't know. Usually, I kind of I don't really discuss it, but at least I present it and give it to the customer for kind of fast check. They can scan it and see, okay, if there's any big issues or mistake, or I maybe did something wrong way. It happens very rare, but sometimes they will say, yeah, no, this breaker has to be in close mode, and we have a parallel transformers, for example. But when I was on site, it wasn't, for example. But that's part of gathering the data for the operation modes most of the time. Once you finish the modeling, we have to do all the studies. So there's a lot of work, but I would just keep it like we have to do all the steps. I mean, all the model, multiple scenarios, short circuit calculations, protection calculations, arc flash calculations. Then we have a first set of results, the, let's say, existing situation on site.
Mhm.
And well, technically, you might stop here, make the labels according to customer style. For example, they might have something already, and then made everything else. But normally, this is very rare for me to do it this way. Normally, we review all the results, analyze the situation. Sometimes I discuss before with the customer if they are looking to exchange some part of the system because they already know that they have to replace something. And then we provide the recommendations for improvements. Recommendations for improvements is like, I think, if you look on the hierarchy of controls, those are 3 or 4 points at the one step. Because this might be elimination, this might be reduction, this might be engineering controls. And that's why I don't really follow steps like this, because you do the same thing almost at the same time.
Mm.
And so, in fact, for example, it will mean that kind of recommendation it will be. So the first thing is not like saying, yeah, you have to improve this or buy PPE. That's not really recommendation. This is just like kind of comment. But normally speaking, it will be like the first thing. That's why we do the protection, because now you unlock the option to make any recommendations for it. So because for protection after, this is usually the compromise. You have to be selective or fast. So that's one level when you can see it and you can improve the settings. That's, I would say, the cheapest one. Technically, you can do. I think that's the trouble. People struggle with it. That's why it's not really always included in the studies, in our study. But for me, it's like generally speaking, this is the first quite easy step to do when you provide the different alternative settings, recommended settings, and it not always leads to arc flash reduction. Because if you have a site overprotected on the medium voltage for 50 milliseconds, there is very little to do. You have to go up, and then when you go up, you increase the energy, and no one really likes it. But then you have the second step, which is hardware improvements. Now you look into all the possible hardware things that you might install in the panel, usually in discussion with the customer, because now this more expensive step. We have to discuss with them, not throw like in last time exchange transformer. In Europe means like 3 years of waiting. I said, okay, that's maybe not the best recommendation that I might see in the report. But then you look into all kind of hardware recommendations. I think I saw it on one of webinar, but this is like changing the trip units on the breakers, maybe changing the fuse size, I don't know, changing the relay type, maybe add arc flash detection, arc flash quenching, a lot of things. At the end, it might mean we have to replace the whole switchgear. It might happen as well. So when you have this done, you write the report. That's an important step as far as I see. You have to write a report. Before this or part of this is creating the arc flash labels. You have to communicate to people what's happening. For the arc flash labels, there are, I don't know, dozens of types of samples, how you can make them. This is like really an irrelevant step technically, because you might create a lot of them every time you want, and it doesn't make really a big difference. Just they need to be proper. You need to have a proper information on it, and I don't know, if you do different shapes, different types, like in IC, I do labels not not in NFPA style, because they don't correspond with IC or ISO signs and the results that we have in Europe. There is no reason to copy paste everything 100%. But then you follow the template, or maybe the customer, but they might have something on site already, which might be good or bad. So it's kind of consulting now. You have to tell them, educated that this is not okay. We have to change this. But this is really irrelevant step. Like on pricing, everything else is like completely. It's very important, but the cost and time and whatever you do, it doesn't make sense. Like doesn't matter really.
Mm-hmm.
I'll do the blue one or yellow or orange or I don't know, black. Makes no difference. And then the very important step is ArcFast training. So this is part of integration or implementation process, I would say. As a minimum, at least, when you have to provide the ArcFast training, it happens different in different areas. Because, for example, in Europe, most people that work as electricians, they have electrician or electrical certification. So they actually follow the shock hazard, everything else. They have to follow this and as the exam and prove that they know what they're doing. And most of those people are really electrical, they have electrical background. So there might be some people that are not exactly educated this way, but in practice that most of the time it will be this way. And so I always sometimes I don't follow, or let's say till last 2 years, I was skipping the shock hazard part because it was technically given by the official body here, like in Poland, in Europe. The few customers, they already asked me if I can include it. So I include also the block for the shock hazard, almost like in NFPA requirements. Then R class, then and we do a few more things here as well locally. And so that's one thing, to provide the knowledge to people so they know what's happening and they know why we do it and how to use it, how to select PP so they can actually play with it. So the training is now like the point where you can do a lot of different things. So it depends really on the person that is doing it. It doesn't have to. At least I don't like when it's really like only presentation. You can actually do something and play with something, play with tools, play with, I don't know, at least with the gloves and things like this, do some rescue and so on. And there is one. So usually you stop here, and then when something is changing, you have to redo the study or repeat the study. Not repeat, update the study every time something bigger change or bigger change is happening on site or in the electrical installation. So the word bigger change or change is kind of flexible, but in practice, every 5 years you will do everything, but maybe day before change transformer or cables or medium voltage relay. I don't know. Things happens. So then you have to update, and that's a big advantage of having digital model. If you did something manually by hand, then you have to redo everything. If you did it in Excel, yeah, you have to redo it, everything. Yeah, digital model is useful because then it's like fraction of cost just to update it. If you change one thing, we just rerun it, rewrite the report, maybe update few labels or nothing. Depends if
Mhm.
it's your Agfas label concept. And yeah, and then we are done.
Yeah.
And
Okay.
so,
That's
and the
that's quite
report
a
is very
process.
important step. Yeah.
Yeah. Marcin, would you say that in addition to being technically competent, being an engineer, do you think it's important for a person to be very familiar with safety standards to successfully run an arc flash study?
Well, you don't have an option really at the end because you have to be, for example, like I can give you like the Poland, but also Europe example. Like everything is related with, like for example, EN 15110 standard, which is the electrical operation safety standard, kind of poor version on FPA 70E. And you have to be aware of all the steps they have to do. Not only calculate it, but also explain why you have to calculate it this way. You have to calculate it, like for example, a lot of people is not aware when they follow 5 and you have 6 steps safe isolation that they actually have to use the PPE at some point
Yeah,
because they think, oh, we de-energize. I said, how do you know? You have to measure, and to measure, you have to get closer. You have to open, for example. You do this, you don't have any, fixed installation for voltage detectors. Then yeah, sorry, you need to
the
have all your
customer should
PPE.
know why they're doing the study and how they will be using it, and ideally, the person that's doing the study should be able to guide them in that. I know sometimes customers get a stack of labels and a report mailed to them, and that's it. Not only they don't get training or any kind of project closeout meeting, they don't even get labels applied to the equipment, and it's just being mailed to them. So, do you see that, and what's your opinion of that style of project closeout?
Well, I see it, but I also do it myself as well. It depends on the customer, technically speaking. For example, I can tell you, like the customers I was talking about, he's not the new customer, and he doesn't require my help. At least I thought that he doesn't help, and and he got all the labels. So, for example, they were shipped to him. He got the RFAS report. We have, well, I always have some kind of like report presentation as part of my projects, which is free option, so no one skip it in PO. So they always have it. Doesn't they don't have to order it. It's for free, and we always have follow up on site. Sometimes like via Teams or something else. We can discuss the findings of the report. I can actually explain what is happening. The report as like one level is explain what is the report about. Not the training, is more like a discussion, technical discussion. And then also the findings that I say, okay, here is the problem, here is the problem, here is the problem. I propose this, but maybe you might suggest, I can suggest that you might install AFAS detection, maybe exchange the switchgear in next year or something. So it's kind of high level discussion to give people background to what's happening on site. And we might fix it, but it's at some point you have to discuss with customer on general level if they are planning to invest money into electrical installation. Because if they don't, it's pointless to tell them you have to install arc quenching system. They are completely not interested with it. It's a waste of time. I can write it. I always write it in the reports, those kind of recommendations as well. But as alternative or optional, I don't know. But but you have to be kind of in line with the customer budget, I would say, what
Hmm.
they are planning, or at least with the plan. Because if something is not that, well, like I would call word tolerable. That's I think the good word because it's not safe, it's not that bad, but you might fix it different way, but not recommended. But the other point, technically, it's always part of training when. So in fact, if someone can't install the labels themselves, means that it's kind of failed training, because this is a really simple thing to do. And if you leave the site and send them the labels and they can't do it, like if there is an electrician or electrical engineer, he doesn't understand what to do with it, it means that you have to repeat the ACVAS training
Mm.
for sure, because this is very simple step. I would say, of course, I always do it. Sometimes I do it myself on site, maybe not always, because I try to train people and then ask them to do it themselves. So they sometimes start with me. Like you can imagine, this is like the huge site with like, they have like 2,000 labels. So they have like kickoff visit when I start train them. Additionally, train them for doing what they work with me for 1 day or two, and then they continue themselves. I think it's
Right.
important that people understand what they are doing. Really, it's not like you see the label and then it's like, okay, that's this.
Yeah, that's a big step, and probably something we see a lot too. That a lot of these companies, well, first of all, they don't know why maybe they're getting into it in the first place, and then after it's done, they don't know what they even have. So, just to switch gears a little bit, can you think of a time that, whether it was a particularly challenging situation or something that you've encountered doing an arc flash study that was maybe a little bit different than your typical arc flash study, something you really had a head scratcher on? And if you can think of one, what was it that you ended up doing to address it? Anything that
Oh,
comes to mind here?
a lot of things like this, to be honest. So, like typical installation is generally typical approach, but for example, if you have like dynamic rotary UPS, I didn't expect to see in industrial side, but they've been there, and modeling them in some of the software is limited. So you have to do kind of work around almost
Hmm.
with R&D of the software, how to do it. So sometimes it's like the simplified step. You know technically what's supposed to happen. So you model one, let's say, state, and then the second state. Then you see generally like, okay, that's supposed to happen. I see the results. I got the calculations, but you don't have this thing in between, because it doesn't behave like this in the model. So you don't have a full, let's say, like the full model, but just beginning, the end for specific study. This might happen as well. Like all the DC calculation, DC arc flash is interesting because it's not specifically not being regulated, but there's very limited amount of publications how to do it, what to do it, and if you don't want to go too conservative on the results as well. Like now I did for the automotive business when they do assembly on the assembly line, and it's completely different story really than normal arc flash. When you actually look from the shock hazard and safety of assembly point of view, arc flash is one of the topic, but not that big, I would say, at least for the moment. Or at least it's very limited and much more risk assessment oriented. So it's not typical arc flash study. It's called the
Hmm.
same way, but the approach is very different than from normalization. When you look on the much more details and you have to go much deeper into the product itself, because it's like kind of one product that goes in 100 times, 1,000 times through the assembly. You want like to be much more precise on what you do. For example, there are probably more results like this, I would say.
Marcin, the being arc flash engineer is kind of interesting because it's not regulated. You don't get a kind of badge or certificate, but it's a very technical, specialized work. That's a function of electrical engineer. The question is, what kind of advice can you give to customers out there that are looking to hire a company or an individual to perform this type of work, but how can they select? Because you don't go out there and ask for, can I have a really good arc flash engineer with 5 stars and not 4 stars? they you know
Yeah,
they
yeah.
it's I can see that sometimes customers struggle with that. What kind of advice do you have for people so that they get a good specialist that understands how to get it done and gives them a good presentation at the end?
Well, uh, What was the good answer for it? Because, for example, in US you have a title of professional engineer. Not necessarily is the same with being expert in arc flash or expert in protection or in generator protection, everything else. So you have to specialize a bit. We have the same in Poland or in Europe. This is very oriented to buildings. If you design the new installation for the new building, then you need to have a, let's say, stamp. You need to have a professional title as a designer, but that's because you also signed the whole project. You are responsible legally for it. But this is fire related, shock hazard related for the design, very detailed. And but the problem is that, for example, I had a last week presentation, training, workshop, I don't know how you call it, for design offices. And so the thing that we do around arc flash and safety is so specialized that as far as I see, it's very limited amount of knowledge, even in the very big companies. I know because I help sometimes. It's not they don't understand. For example, they don't focus on it. They do completely different type of engineering. So what is my plan as well? It's for example in US it's easier because you might do NFPA. It's train the trainer training. Kind of, it's official certificate that you might do, but it's more for people which are electrical safety specialists in the company. What John told me that where you were starting, probably that's if you have it, that would be a very nice thing to have as an EHS electrical safety manager or specialist in the company. Not necessarily means that you know how to do the arc flash study itself, because it's kind of specialization under power system engineering. I would call not even below electrical engineering, but below power system engineering as a whole. So that's why actually I'm not doing only arc flash studies. That's the point. I'm doing all the power system studies that I can do normally, and it means protection. That's why protection is included in arc flash as a standard for me. I do a lot of protection studies and load flow and motor starting recently and across different industries. Probably industrial is the biggest one, but it's also marine and I don't know, like automotive is industrial as well. But all the DC systems, data centers, and things like this, they are not per se arc flash study project. They are more like power system engineering study, and arc flash is one of the topic in.
Mm-hmm.
So hard to say. It would be nice to have some certification for it. And at least say, yeah, I know what I'm doing, and the paper, I don't know, certificate saying this. The only thing maybe you might ask about the experience, probably. But this is a bit unfair if you are new and you know what you are doing and you're starting the business or company or yourself. Then it means that you have to work somewhere for a few years before you can jump into it. But
Yeah,
yeah, most of the time it works this way out, I think.
probably with mostly anything. So across all the projects and different companies you've worked with, what would you say is the most common misconception that people have about arc flash and arc flash studies?
Well, there's, I would say a lot, but they come from different angles. For example, last time I saw on LinkedIn that someone said about the low voltage. I posted the accident on low voltage. Tell them to reconsider this.
Yeah.
Uh, but the low voltage, high voltage is the main thing related generally with electrical safety. Tend to be afraid of high voltage or medium voltage systems as a rule of thumb.
Mm-hmm.
But for the low voltage system, they just think it's okay. That dangerous, like yeah, that's okay. The second thing, as far as I hear, but this is coming more from technical side of engineers, or I don't know if this is US or Canada, but I hear very often as well that, for example, arc flash is not that common. If you look for the statistic of Bureau of Labor in US, this is more or less 50% of accidents because they are recording arc flash and electrical burns as well.
Mm.
If you look on the numbers, it's half. not really not that common. Yeah, it's almost the same as shock hazard. Probably it's part of the shock hazard as well for the same accident, but yeah, it still happens more than one times per year. At least I know about few accidents, few fatalities in Poland this year.
Yeah, that's
It's
really
not that.
interesting because the numbers that they cite in NFPA or in CSA, it does seem you're right. It does seem like they make it look as if arc flash is far less common. And so you're saying that maybe from your own experience or what you've been able to dig up that it's a little bit more common
Well, it's
than
not
people
from
think.
my experience. It's from the numbers I see on the Bureau of Labor or about the statistics they show. If you look on the ASV Electrical Safety Foundation as well, when they do very nice infographics about it from it,
Mhm.
then you look inside and you see, okay, it's almost the same amount of a little bit less. Still, it's not 10%. It's more like 30-50%
Mm.
of the amount of accidents as shock hazard. It's almost this. It looks like it's the same. It's not my really. It's not my opinion. It's just the statistics and numbers I see. So because in Europe they don't track electrical burns or electrical shock hazard separately. It's all in one box. Hard to say.
Hmm.
But from what I see from US, it doesn't look that uncommon thing to happen, unfortunately. And the second thing, if I have to say, so the medium voltage, high voltage is one of the thing. The accident rates, and the last one, like generally, there's a lot of misconception about the PPE. But I think it's driven from the other side, from the PPE suppliers or manufacturers or sellers,
Hmm.
where they either lack of knowledge or they cut the corners. They don't read the standard only, because that's a very simple thing to do, to be honest. And there is a lot of things around it about the gloves. In Europe, it's a little bit different because I would say in NFPA, in Canada and US, you have NFPA and CSA, which is kind of like a guide, not even the small one. I think I have one here. Not really a small guide. If you keep it, you can read it, and generally written in kind of guide form. Like you have to do this here and here and here and follow those steps. We have the same in Europe, but there is no really nice guide form or operation. Everyone need to have some kind of instruction on electrical safety plan, but there is no, let's say, very high level guidance on top of it. What you have to
Hmm.
do, what you have to do with this, what you have to do with this, how to. Or you have to kind of jump into the IEC standards every time, and not, at least for me, it's not really the good solution for it. So and I think that's why people struggle at some point with generally simple tasks as selecting PPE. Also, it's a relatively simple task, and I would say those are the most common things I can hear, and then they are, let's say, on technical level, like low
Hmm.
technical level. Because if you go into the medium and high technical level of problems, then all the topics related with the protection and not misconception, it's like lack of knowledge, I would say.
Yeah.
We have to do it, and why it's not supposed to be this way and this way. That's sometimes completely different level, I would say. It's not even that you have to discuss something, you just have to show it at the first place and explain.
Mm.
So that's those are the topics that generally I have most of the time. And of course, but this is not misconception. This is the again missing data kind of competition problem where you struggle with the scope of work. That's what we discussed in the very beginning.
Mm.
What, how this supposed to look like? That someone send you the papers and the labels and say, yeah, it's fine, enjoy. It's 80 calories. Good luck. It's more like I think I've seen it somewhere. Like there are requirements in IEEE 1584.1. They might be locally adjusted, I would say, because sometimes something is more required, something is less. But generally speaking, there are some certain steps that's supposed to be included because of the reason, not without the reason. But you need to have this, you need to have this, because you have to see if something is rated properly, something is protected properly, and then you have to jump into the making some stations or collecting PPE.
Mm-hmm.
And if someone doesn't do it, of course, it's less work. It's less lower. You might, you don't win this, for example, and then you come back to the customer sometimes and they say, yeah, we have this, and they show me, for example, one page laminated with the table,
Yeah.
and that's the whole study. That's the
Yeah.
whole thing that they got. Yeah, okay, maybe not the best way.
Yeah.
So
So
it's
that,
hard to say. I think that there's a lot of myths or misconceptions. I would say that's the better word for it.
yeah. So I guess things can, people can look for is just maybe to educate themselves a little bit more before they do start one of these projects. We are coming up on time here, Marcin, so I want to thank you for joining the show. Just one last thing, I guess, would be for yourself. If there's, what's the best place if someone wanted to reach out or look you up? Where would they go to find you?
Well, definitely on LinkedIn. If they find me, type my name, Marcin Ruta, on LinkedIn, they will find me definitely. Of course, they can go to the website as MR Power Tech, which I didn't figure out that it will be read in English as Mr. Power Tech.
Right?
MR comes from my name, like Marcin Ruta, Power Tech.
Yep.
It's still fine. I can live with this.
Yep.
They can
Not
find
the
my
worst
contact details
abbreviation
there.
out there.
Yeah.
Yeah.
Well, this comes later always, so I didn't expect it. So they are free to, if someone has a questions, I'm free always. Usually when I'm available, I try to answer as soon as I can. Generally the
Hmm.
questions related to electrical safety, not only the offers and technical questions, but if someone just struggle to find some data or information, or just looking for answer and doesn't know what's happening. I try to at least guide people in a certain direction. Just go here, look there.
Hmm.
That's why you've seen a lot of webinars and all the technical articles or YouTube channel. People actually can read it, watch it, and maybe learn something. Yeah,
Yeah.
this
So
way.
we'll make sure to we'll link to everything kind of in the show notes. And yeah, so thanks so much for coming.
Yeah, thank you very much for inviting me and having me here. It
Hey,
was nice to
Marcin.
talk.